So what is the bootstrap in statistics? It's a way to compute standard errors of any quantity of interest without using assumptions. So first, the classical approach, where we have a population, we draw a sample, we're interested in estimating a quantity of interest, let's say a mean difference, a correlation, and we need to compute the variability, the standard error of that estimate to get p-values. And basically, it's an exercise in math that is all implemented in the software. So these days, we just use the software. The problem is that math relies on assumptions. So the Bootstrap takes a different approach to help us when we're not sure of the assumptions behind the math. So we have a sample, let's say of 100 patients. The idea is to resample the data set we have with replacement. So what does that mean? For example, we have our 100 patients, we put them in a hat, we're going to resample 100 of them. But if we don't put them back in the hat once they're sampled, we're just going to empty the hat and pick out the 100 same patients. It's not going to change anything. So the Bootstrap puts them back in the hat after they're sampled. So we take one out, we note the observation, we put them back in, we shuffle the hat, we take another one out. We do that 100 times. So some patients are going to be overrepresented. They're going to be there 2, 3, 4 times maybe. Some patients are not going to be represented. So this is going to create some variability. We compute the estimator, the mean difference, the correlation, whatever. But we repeat this a large number of times. I usually do 1,000. So we'll have, if you see up here, 1,000 resampled data sets, and on each of those we compute the estimator of interest, and we're going to have a variability in our estimator, and we're going to use that variability as an estimate of how variable our original estimator is. So we're going to essentially get formulas for standard errors without any assumptions. A little caveat here, the method's not magic. If your data is bad, the results will be bad. But there's a bunch of corrections that we can bring to the algorithm that are outlined in this book, An Introduction to the Bootstrap by Bradley Efron, who was actually the guy that invented the method in 1971. And for the little story, we have to understand that at the time, statisticians were busy doing advanced math. So they were looking for formulas to compute standard errors, and they would have to do a lot of complex math to get them. This guy just came out and he's like, hey, let's pick ourselves up by our bootstraps and just resample the same data set a bunch of times. People thought he was crazy. Computers were slow at the time, so the method wasn't widely applicable, but he was actually way ahead of his time because he understood that computers would become faster, and he was right. Today I can use that method. It takes me a second to run it on my laptop. And he also wrote a book, Computer Age Statistical Inference, which came out recently. So this guy's pretty old now, but he saw the evolution of statistics and he wrote about it. So in the book, there's 21 chapters that each explain a method that was either invented because we had computers to invent the method, like the Bootstrap, or that were kind of modified or ameliorated by the use of computer power. So all these methods would probably not have been thought of if we didn't think of them in terms of algorithmic computing procedures.